Whenever we can't quite reach something, we use our upper body muscles to lean over and grab that object. And these upper body movements are called compensatory movements because essentially your upper body is compensating for the length of your arm. And these upper body movements, they take a little bit more energy, they strain your muscles a little bit, but it's not that big a deal because we don't do it very often. But for someone that's lost an arm and now uses a prosthetic device, these sorts of upper body movements are how they go about regular, everyday tasks all the time. Because body-powered prostheses are operated by shoulder shrugging movements like this, shoulder rotations, and generally leaning toward the object that they're trying to interact with. Even people that use electrically powered prostheses will tend to lean toward an object rather than using the motions in their arm to get there, because it's easier to think about. It's more intuitive. And these upper body movements, in addition to still requiring a lot of energy, can actually result in overuse injuries, because these muscles are now being strained so much more regularly and often than previously would have been the case. So how do we solve this problem? I mean, we already have advanced bionic limbs that can move in pretty much all the same ways that a human arm can. So I suggest we take it one step further. My research focuses on designing and evaluating new prosthetic technologies that reach beyond the capabilities of the human limb and extend the boundaries of how we perceive prostheses. Starting with this simple extendable forearm prosthesis, so just this section of the arm here that extends and retracts about 6 inches, I'll be able to look at some first very interesting questions about how people might interact with a device that has different capabilities than their own bodies had. Watching people use this device and watching them using motion capture and eye tracking technology, I'll be able to quantifiably analyze how these upper body movements are changed and hopefully reduced when interacting with a device like this. And then using this reduction of compensatory movements as a quantifiable goal, I'll be able to see what kind of design changes need to be made in order to make this prosthesis more effective and more intuitive to use. So going through this iterative design process of prototyping, testing with real people, updating and evaluating the design as necessary, and repeating, well, I hope to be able to make a prosthesis that will revolutionize the way that we perceive the capabilities of the human body. By making bionic limbs that don't just meet, but exceed the capabilities of the human body, I hope to be able to offer amputees the opportunity, not just to do things they used to be able to do, but to do things that no one has ever been able to do. Thank you very much.